The useMemo hook accepts a function and a list of dependencies much like the useEffect hook. It returns a memoized, yes it is a weird word, value. What's special about this memoized value is that it only is recomputed when there is a change in one of the values in the dependency array. The dependency array you pass is important. If you don't pass in a dependency array to the useMemo hook, its contents will be regenerated on each render, thus undermining its use. The use of the useMemo hook is quite simple. To hammer the point home, the function expensive computed function above will only be called when either dep1 or dep2 in the dependency array changes. Much like its sibling of sorts, the useCallback hook, the useMemo hook is usually found when it comes time to profile your application for performance optimization. The best employment of this particular hook is to prevent multiple frequent calls to functions that are computationally expensive, especially when their expected value hasn't or isn't expected to have changed. These extra calls can create optimization bottlenecks and are largely unnecessary. You'll often find useMemo used when dealing with big data items such as graphs, charts, plotting data, and dealing with large mathematical equations. But we do have some optimization caveats. It's worth a quick mention here that there is a temptation to over-optimize your code, either too liberally or too early. For me, optimization should be kept in mind, but it should be based on much more empirical data as possible. Try to resist the temptation to pepper your code with useMemo and useCallback at every opportunity, as the complexity you add and the readability you lose are often not worth the trade-off for slight gains in perceived performance. Before going on, I'd recommend taking a quick look at the excellent hooks reference site usehooks.com by Gabe Ragland. We'll be using a modified version of Gabe's useMemo example in our demo here. For this demo, we don't have any extra styles to add, so fire up the useMemo example.jsx file and let's start by defining some imports and helper functions. We'll be using a few hooks here, so we're importing them up front. Next, our helper functions. With getTimeDifference, we want to be able to work out the time that has elapsed between a passed-in start time and an end time. The passed-in times here will be standard JavaScript datetime values, and we work out the difference using the modulus operator and divide the result by 60 to arrive at a value in seconds. For count letters in Word, we're employing a bit of a cheat here, or at least a forced expensive computation. In the real world, we'd be looking at big data calculation or maths equations, processing functions, but here we have a simple while expression that increases a counter I around 3 billion times. Once that's finished, the function just returns the length of the string word that we pass in as an argument. We'll be memoizing the count letters in Word function later on as we pretend it is a computationally expensive function. Now for the main event, defining the default component export. Let's start by scaffolding out the component before filling it in. First up, we need some variables. For starters, we'll add some non-hooks variables. WordList is an array of random strings that we're going to use to count later on in the component. Meanwhile, timestart is set to a brand new date result that will represent the date timestamp of when the component first renders. Next, we need some state values using useState. The variable count will be increased each time we click a specific button, which we'll define in the upcoming JSX. With computed time, we'll keep track of the time it takes to count the letters in each of our words when the next word count is triggered. And finally, current word will hold on to the current word that we're counting the length of. Now to define some functions, and most importantly, use our new hook. You can ignore the commented out line for now. We'll come back to this when we run the final app. It's going to help us illustrate an important point, but we can skip over it for now. The first function, handle load next word, is going to be called from a button click that we'll add in shortly when we build out the JSX. It looks at the array of words, word list, and works out the index of the currently selected word. From here, it calls setCurrentWord to update the current word held in state. It does this by grabbing the next word in the word list array and incrementing the word index by 1, or setting it back to the start if it's going to overshoot. The next function is where things get spicy. We're finally calling the useMemo hook, passing it an arrow function that returns the value from the count letters in Word function we defined earlier. This function is supplied the current word held in state. We're also using current word in the dependency array so that when this changes, we'll run the memoize function again to get the new word count. The last bit of logic for us to get down is to use the useEffect hook to work out how long it took to render the component. Again, we're using the current word as a dependency here, so that when it changes, we work out the time difference using getTimeDifference we defined at the beginning of the file, passing in the start time when the component began rendering and the time now when we call this function. This doesn't have anything to do with the workings of useMemo, but it will allow us to visually see how long each word's letter count computation took to complete. Our final task is to add in the JSX so we actually see something when we load this puppy up. Underneath the heading level 1 element we have in our skeleton JSX, let's add the following. The first paragraph gives us a nice reference to the current word held in state so we can see what's being calculated. Next, we get down two buttons. The first will load the next word in the array, called the handle load next word function we just defined in the last section, whilst the second button calls an inline arrow function that updates the count value in state. The final two paragraphs are further visual niceties to highlight what's going on in the app. The first line shows the currently selected word and how many letters it has once it's been calculated. It also outputs the estimated time it took to count the letters in the word. The second paragraph lets us view the count value in state, checking to see if it's 0 and displaying a slightly different message if the count hasn't been touched yet. So sure, it's not much to look at, but it does a really great job of illustrating the benefits of useMemo. You can see that on initial page load, and every time we hit the load next word button, our mocked expensive function is called and the time difference is calculated and then output to the screen. Each word takes about 2 to 3 seconds to count. Because the currently selected word is changed each time we hit that button, the memoize function is rerun, the component re-renders and the output is updated. If we hit the notch up the count button, the component re-renders all the same, updating the output. Notice how the count is increased, but this time the letter count variable is using the memoized function from count letters in word function. That's because, although the count variable has changed, the current word variable hasn't. Because this dependency hasn't changed, we don't need to rerun the expensive function, we can just use the memoized value. Just to hammer home how valuable useMemo can be, let's hop back to the useMemo example component and swap out the letter count variable with the commented out letter count line. Just delete or comment out the first line, which uses the useMemo hook, and uncomment the very next line, which is unmemoized. Reload the app and you'll notice that not much has changed when you hit the load next word. However, if you hit the notch up the count now, you'll see that it takes ages to simply update a single number by 1. This happens because the component is re-rendering, but instead of being able to use a memoized value for the letter count variable, we're having to work it out afresh each and every time. We shouldn't have to because the currently selected word is the same, but by not memoizing the returned value, we perform the calculation on every re-render. You can see how valuable and useful this single line can be when it comes to optimizing our simple app here.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.